just a reminder about last day, when we worked on this booklet. How many moles of ammonia gas can be produced by reacting 6 moles of hydrogen gas with a sufficient amount of nitrogen gas? The first step that we did was that we wrote a balanced chemical reaction. Step 1, balanced chemical reaction. Okay? You don't just follow along the board. You don't even need to look. I'm just going to go through this quite quickly, and then we're going to move on to today's stuff. So here's the step 1, balanced chemical reaction. Then number 2 was to write your information underneath the thing that's talking about. So here I've got how many moles of ammonia gas. So here's my ammonia gas. I'm writing N equals question mark. Remember that? And then it tells me 6 moles of hydrogen. So under here I'm writing N equals 6.00 moles. And we talked about, I'm going to write down 6.00, not just 6, so that I remember my significant figures when I get to the end. And I am working sort of within this column, and I'm trying to transfer it over to that column. And right now this is sort of the first baby step out of what's going to be quite a few steps. So we said if you need 3 of these, according to the balanced chemical reaction, to make 1 of these, then my ratio is 3 to 1. So I don't have 3 moles, I have 6 moles. I must be making not 1, oh pardon me, 3 to 2, sorry, 3 to 2. I must not be making 2 moles, I must be making 4 moles. And we talked about a variety of ways of answering this question. One being just ratios. If you're the type of person that loves ratios and gets that 3 to 2 is 6 to 4 and I'm good to go, then you should use that way. If you're the type of person that likes units, and I want everybody to understand this because this is the way that's most proper that I will be doing, is that we had in our question, just a second, it's not letting me scroll down. Oops. Nick and James, I need you to stop talking. In our question, we had 6 moles were given to us of H2, and my ratio, 3 of H2, 2 of N2, I want the H2s to cancel out. So I'm going to put the number for the H2 down here. So that's a big 3 from the balance. And the NH3 is going to go up there because that's what I want to end up with. And then my H2s cancel out, and I'm left with the ammonia, which is what I want my answer to be in. And so I take the number 6, I multiply that by 2, and divide that by 3. This is kind of really important when you don't have a lovely 6, but you have a 6.5 or a 0.983. So your ratio is 3 to 2, and you have 0.983 to what? And even the best ratio people out there are starting to sweat just a little bit. And so if you remember that you times it by 2 and divide by 3 because you're canceling out the units, that's the best way to do it. And then I said, if both of those things kind of freak you out, and you're not understanding this, and you're not understanding this, then what you need to remember is you times, remember what I said yesterday, or last day? You times where you're going, so I'm trying to go, this was N equals question mark, and divide where you've been. So you times by 2, divide by 3. Remember that? Can I see some nodding or shaking of heads? Okay. That is now our middle step in our next topic. Okay? And I said that I needed to see that ratio because now I can give you 1 mark out of this question even if you get the beginning and end steps incorrect. Okay? So, flipping down to where it says gravimetric stoichiometry. So gravimetric is a fancy way of saying masses. Okay? So sometimes you're asked for or given mass, whereas all of last day you were told number of moles and asked for number of moles. But what if they don't do number of moles, but rather a mass, and that's more likely. I'm going to react to certain mass, right? Go and weigh out 5 grams of it and dump it in the beaker. I'm not going to say to you, go and weigh out 0.98 moles of it. So it's more likely that you're going to get a question with mass. So all we need to do is convert mass into the moles. And then we're back to what we did Thursday. So how do you do that? How do you convert mass into moles? Number of moles equals little m over big M, mass over molar mass. Now I can get in the moles and I can go back to that last thing we just did. Mole ratio. And then what if they end asking in mass? So what we did Thursday gave me number of moles of my question mark. Can I convert that into mass? Mass will equal number of moles times my big M, my molar mass. So not any harder. I'm not throwing a new formula at you. I'm just saying sometimes you're going to have to figure out the moles first. Okay? So here's an example. Copper metal reacts with silver nitrate to produce silver metal and copper nitrate. What mass of silver can be produced by reacting that number of moles of copper? So the first step, the same first step that we had last time, was to write a balanced chemical equation. So James, what have we got going on here? Mm-hmm.
Like copper metal reacts with silver nitrate.
Yeah. So what do I write down for my balanced chemical reaction?
We'll write down copper. Just plus AgM. And the copper's going to be solid. AgM is going to be an Alright, it's going to produce silver metal and copper nitrate, copper 2 nitrate.
Okay, can you give me the symbols, please? For example, that's not what I should be writing. Can you see the board from back there?
Yeah.
Are you sure? Because you haven't been really paying attention or looking or watching at all, even when you're doing this example. All right, so if you can see the board, then you have no excuse. All right, so what symbols am I going to get now, James?
You're going to get AG
Mm-hmm.
and CU NO3
All right, well done. Keep looking. Nitrate is a 1 minus.
Yeah, that's what I was
Yeah. So therefore, I need a little 2 there.
Yeah.
Okay, and then we need to balance it. Emilio, you're on.
Oh, you need 2 in front of AG and 2 in front of AG and 3.
Emilio, all right, everybody?
Yeah.
Is that now balanced? Good. Okay. Step 2, same as it was last time. I now write my information underneath. So what information have I been given? What mass of silver? So M equals question mark. By reacting that moles of copper, so under the copper I'm writing 0.250 moles. Everybody okay with that? Information and how I drew it out? Okay, so Lane, all the information is in this column right now. Where am I headed?
To find the ratio, the 1 to 2 ratio.
Good, I'm going to use this 1 to 2 ratio to cross my streams. So this is the analogy I give. Here's one stream, here's another stream. I need to cross the bridge to get from stream to stream. So how you cross the bridge is you have to use the ratio of 1 to 2. So my ratio is 1 to 2. What do I need to do to this number? 0.250 moles. What do I need to do to that number? Multiply or divide by 2? Multiply by 2. Times where you're going, divide where you've been, if that's what you need to do. use your units. Moles of copper divided by copper. So silver must be on the top. All right, so times it by 2. And how many moles of Ag do I end up getting then? So by doing this, I end up with 0.500 moles of silver. Does the question ask how many moles of silver? No, the question asks how much mass of silver. So can I go from number of moles to mass? Yeah, quite easily, right? So what do I need to do, Liam? What do you need to look up?
The molar mass of silver.
Good. So mass is equal to my number of moles, grams, or times, what's your molar mass of silver?
107.87.
107.87 grams per mole. You can see that the moles cancel out, and I'm left with how many grams?
Well, you have to have 2.
Yeah, you have to have 2.
Oh, no you don't.
But you have 2 AG.
I've already taken care of this too. Here. When you calculate the big M, like you did in Science 10, you never worried about the balanced. The molar mass of silver is 107. This little 2 I would have paid attention to, because the molar mass of that compound has 2 nitrates and 1 copper in it, regardless of the big number here. So little 2's you pay attention to for molar mass, but not the big 2. Okay? The big 2's already been accounted for when I cross my bridge. And so, who's done that in their calculator? Taylor, view?
53.9.
Look at your nails. Fancy.
53.93.
53.93 grams. Okay? So that's a lot of silver I've taken out of there. What mass of copper would you have had to have put into this? What mass of copper?
26.96.
How did you figure that out?
Divided it by 2.
So that's how many moles there, right? Okay. So you this eraser. You're kidding me. Okay. Copper, solid. Okay, and my lines are in blue, like that and like that. Okay, so I asked you what the mass of copper was, right? And you said it must be the number of moles times the big M of copper. Is that how you did it? 63 point whatever it is. And so 0.250 times 60. 3.45. 55. And what did you get?
15.88.
15.88 grams. So, another question might have not given you moles, but given you mass. And then asked you to solve for the moles. So you go down that stream, you go across the bridge, and then you go down that stream to find the answer that they're looking for. I'm sensing you're okay. So, is there a second? Is there a second on this sheet? A second example? Okay. Try this example on your own for 3 minutes, and then I'm going to put the answer on the board and see how you've done. Oh, it's gone. Oh my word. Right, sulfuric acid, H2SO4, neutralized by, do you see why I want you to memorize sulfuric acid right at the beginning? Remember how I said there are 2 acids I want to memorize, this is one of them? Because now it's faster. Sodium hydroxide, NaOH. How much easier is that if you've already memorized that hydroxide is a 1- and sodium is a 1+, without having to look it up? Sodium sulfate, you might have to look up, but it already says what mass, so it must be a precipitate. You don't have to look that up. And you're going to get water because it's a neutralization, so you get a salt and water. And this is liquid. Okay, obviously. So what mass of sodium sulfate can you get from reacting the mass of 14 grams from sodium hydroxide? That bit there should not take you very long to set up. Yes?
You didn't do the first step.
No, don't we have to balance?
Oh, I need to balance it. Sorry, I had the other one balanced, but then it rubbed off on me. Okay? So, hands up if that took you a while. Who was willing to admit to that? Okay, so that needs to speed up, otherwise you're going to run out of time on a test.
I did it right, just didn't memorize the steps.
Okay, so you've got to start memorizing Na1+, sodium hydroxide, NaOH. You should have used those things so often now that it's not a conscious memorizing, it's a subconscious memorizing. Okay? All right, and hands up if they were very proficient at that stage. Meaning that was really super fast as me. Okay, good. Okay, well done, you guys. Okay, so I'm going down this column, crossing, and then trying to get up to that column. So the first thing I need to end up at number of moles. So how do I do that? I go mass divided by molar mass. So 14 divided by 40. I ignore the big 2 at this point still. And so 14 divided by 40. Pardon me? 0.35 moles. And my next step is to cross the bridge, right? So cross the bridge to the other stream. How do I do that? It's a 2-to-1 ratio. So I'm going to take my answer and I'm going to divide by 2. And so 0.35 divided by 2 is what?
175.
Oh. Thank you. And then I now need to solve for what I'm asking for, traveling down this stream. So the mass is N times big M, so 0.175 times, what's the big M of sodium? 42.05. Multiply those together and you get what for a mass? Pardon? 25 grams. Okay? You have to show all your work for those points. And then we'll practice. Tomorrow we're just practicing. There you go.